All right, are we rolling? I think so.
Yep, you're all good.
All right. Hello, everyone. Welcome to the humidification webinar. I'm joined today by Ronnie from Neptronic. He has over 18 years of experience in HVAC. He's a mechanical engineer, and he's an expert in all things humidification. So I hope you guys gain a lot of value from this presentation. It's a pretty interesting one for me as well. So yeah, Ronnie, off to you.
Thank you, Abdul. So thank you everyone for being here this morning. As Abdul said, we'll be talking about humidification, mostly application products, right way to design, to lay out humidification jobs. And at the end, I'll take all the questions you guys have. So feel free to ask any question, or even during the presentation, if you feel that you're missing some information I'm talking about, just, let me know and we will go through it. So we have a lot to cover, so I'll try to cover as much as we can during this presentation, and I'll take questions at the end. So why we need to humidify? Most of you already knows why we need to humidify, but I'll go very quickly on it. So if you look at the humidity itself, it's mostly constant the whole year. So it's not humidity, it's not really the big issue for humidification, is the temperature. That's where we have a big fluctuation of temperature between summer and winter. And that's mainly the reason we talk about relative humidity. It's relative to the temperature we're talking about. So if I take, let's say, a bubble of air at 30 degrees Fahrenheit in winter, even if it's 80% relative humidity outside, as soon as I take this air and I heat it to the 70 Fahrenheit inside air condition, now I have only 18% relative humidity. And that's mainly why we need to humidify in winter, because the more you heat the air, the more it can retain water and the more you need to inject humidity inside of it. So what's typical application where we need to use humidification? Any application actually needs some sort of humidification. So if you're talking about museum, libraries, you need to maintain a certain level for the arts so they don't start cracking. Offices, hotels, schools, it's more for the comfort and the health of the people inside. Clean room, data centers, pharmaceutical labs, hospital, operation room, printing industry, tobacco industry, electronic industry, any industries need some sort of humidification. So for years, for years, everyone was talking about the optimum zone of humidification between 30 and 60. So if you have less than 30, you can have different type of bacteria, viruses, or infections. And if you have more than 60, you will have different type of problem like mites, fungi, and other problems. So when COVID hit, there was a lot of studies related to the indoor air quality and specifically humidification, and what role humidification plays in the air condition and the quality of the air. Sorry, give me a sec. So, and specifically, there was a doctor called Stephanie Taylor. She did a lot of studies on this, and her finding is, if it's dry in the air, the virus can stay floating for 41 hours before it drops to the ground. And the virus diameter is so small, it's about half microns, and it can infiltrate easily into our bodies. Now, if you inject enough humidification in the air, this bubble of virus will catch the water of the humidity and will inflate. So instead of being half microns, it will be about 100 microns, and it will get big enough to be heavy enough to drop into the ground into 6 seconds. So by being inflated, it's not just dropping quickly, it's harder for the virus to infiltrate the body because it's bigger than the places where it can go through your body. So based on these findings, the 30% minimum level that everyone was talking about does not stand anymore. Ideally, we need to maintain 40-45% to be able to really control the virus and control the healthy environment. We need to be around 40-45%. So between 40-45 up to 60%. So now, if you guys are designing a job, what type of information Odell would need from you to be able to give you a selection and help you designing a humidification job? We need to know what's your outside temperature and your design conditions. What's your inside condition that you want to maintain? We need to know what type of equipment are you using. Are you using 100% outside air? Are you mixing the air? Is it like just natural open window space? And we need to know where you want to put the grids. Is it inside the air handling unit, the duct, and the space itself? All these information is important for us to be able to give you a selection, and definitely we need to know if you're going with electric, gas, or you have an existing boiler. Now, one point that a lot of customers don't know the answer for, but it's really important, is the water quality you're dealing with. So depending on where you're installing the job, in some cities or some area, the water quality, the tap water is fine. In other areas, they are very hard water. Hard water means there's a lot of calcium, magnesium inside of the water. And we need to know that because that will have a big effect on how the unit will operate. If you look at this picture here, that's an old picture that was taken from a job site in Calgary. The water was so hard that it built so much scale inside the tank, and now the unit is done. So we definitely need to know what type of water we're dealing with, because we always have a solution. If it's a hard water, you can go with water softening or reverse osmosis. I'll catch very quickly on the RO system at the end of the presentation, but you need to know this type of information. It's really important. So when you're designing a humidification job, you have basically two options. Even you go isothermal or adiabatic. Isothermal, it means you're just injecting steam in the space. So as you see on the psychrometric chart, it's just adding steam. So you're using an external source of energy to create the steam. It's even gas, electric, or pressurized steam itself. Adiabatic, as you can see, you are cooling down at the same time as you are adding humidity. So you are extracting the heat from the space itself to create the evaporation process. Most of the application we have in this area of the world where it's cold in winter, it's gonna be isothermal. But there's still some application where adiabatic makes a lot of sense, which I'll touch base on a couple slides. So what type of products you have when you're dealing with humidification? If you go with the isothermal products, you have electric units, gas units, steam to steam unit. That's what we call atmospheric steam. So there's no pressurized steam. And then you would have a pressurized steam coming from an existing boiler in the building. On the adiabatic side, you can have the high pressure system or the evaporative media. So when you start designing, let's say you decide to go electric, you have two options on the electric. You can even go electrode or resistive. So what's electrode? Electrode, that's, as you can see, it's usually a white plastic cylinder. Inside of it, you have electrode rods, and it works only with conductivity. So the only way to use this technology is by using your city water, because if you go with RODI, that's very pure water, there's no conductivity. If you go with water softener, it's not a solution neither, because water softener, there's a lot of salt in the water, which create a very big peaks of conductivity, which will not let the unit operate. So ideally, you want city water, and the ideal range to operate an electric unit for city water, the hardness should be between 6 to 8 grain of hardness, which is very low. Like in a lot of cases, the hardness are way more than that. And how the unit works, it starts heating the water, and then you will get steam out, and then part of this electrodes will get scaled up. So you will use another part, until all of this unit is filled of scale. Then the unit will tell you, okay, I'm filled of water, I'm not generating any conductivity. That means I need to change my plastic cylinder. Now, the problem with this unit is that you don't get any precision out of it, because as you see, the unit takes about almost an hour to create steam at first, because it needs to fill, drain to build up this concentration of minerals to start giving you steam. And then will always operate plus minus 1 to the plus minus 10% the whole time. So where this application makes sense, first, as I said, depending on the water quality, if you have the ideal range of water quality, it's fine. And for comfort application, where a human being don't feel the difference between 40% or 45 or 50% relative humidity. So that's where it can make sense. The other option you have is the resistive unit. So a resistive unit, as you can see, once you open the tank of a resistive unit, you have heating element here. So instead of having electrodes, you have a heating element. By having heating element, you can use any type of water. So you can use city water, softened water, RO, DI, it doesn't matter, because you're heating the water with element. And by doing so, you get much more precision out of it. So you can, because this unit will modulate from 0 to 100%. And let's say you have a pharma application or some process application where you need to be plus minus 1% precision. You go with this unit, you use the SCR on it, and you definitely need an RO system before the unit to achieve precision. Now, don't get me wrong. Sometimes when I present this, people think that for resistive, you always need RO. You don't. Like, you can run it on city water and use it for all type of application. But why I'm saying for precision? Because this unit, if you are using city water, the unit need to go into drain cycles every 4 to 6 hours, depending how bad is your water quality. And why? Because if you don't go through drain cycles, it will build up so much scale and you will damage the unit. So between the time the unit is draining, refilling, reboiling, you lost your set point. That's where you don't achieve your plus minus 1%. Now, if you put an RO system before the unit, that's pure water. So the unit don't need to drain every 6 hours because it's not scaling up. So you can run it the whole process time. I'll give you a quick example. We had a job at a painting booth at an automobile factory. The customer installed one of these units, the resistive ones, without RO system. And he needed to run the unit the whole day because the process for painting, it runs the whole day. And he started having troubles with the unit, like, draining, and he's losing set points, and it's not good for the painting. So once I went on site, I explained, and I saw what's the application. I explained to him that was a wrong application, not having an RO system. You always need an RO system for these type of precise application or long run application where you can't stop the unit. And there's a bunch of brands in the market for this type of units, depending what brands you're using. Some are more hard to get access to the tank to clean. Some are easy to get access, like the one I'm showing here. It's very simple. You just disconnect the water inlets, you slide your tank. Usually all the scale is inside this tank. So you take the tank out, you clean it, put it back in, slide it back up, you're good to go. Now, most of the time, if your water quality is fine enough, and when I say fine enough is less than 10 grain of hardness, all the scales inside this on this heater will fall inside the tank by expansion contraction. So anytime the unit is stopping to drain and then refilling, the scale inside here will fall on the heater, will fall inside the tank. So you don't really need to clean the scales on the heater. Now, interesting fact, to go back to the same example I spoke about, the paint job. The customer told me, oh, well, the scale is not falling from the heaters. I mean, definitely it will not fall from the heater if you're running the heater the whole day, because there's no time for the heaters to get cooled down to create this extra expansion and extraction movement. So for the heaters to be able to literally kind of move to let the scales fall down, it needs to cool down and heat. If you're running the heater the whole day, well, the unit is not doing that. And that's why when you use city water, you drain every 4 to 6 hours to allow all the scales to go through it. So, and usually on the electric side, you always have capacities depend on the brand you're using, but most of the brands will work from 6 pounds up to about 300 pounds. So it does cover a big range of capacities, the electric units. And most people will use electric units, as I said, for like precise application, even comfort application for office buildings and stuff like that, where you don't need very big capacities. Now, the second option you have is the gas humidifiers. Again, on gas humidifiers, depending which brand you're using, you would have 2 options. But why people will go gas? Most of the people will go gas because gas is cheaper than electricity in a lot of states in the US or provinces in Canada. I believe in Ontario, gas is cheaper than electricity. The only place I know that electricity is cheaper than gas is where I live in Quebec, but that's why people used to go gas. But the recent years, even in Ontario, people are trying to move out from gas because, you know, for environmental aspects and trying to stick to electricity. But gas, it still has its market. So you also have the options to have the units outdoors. Why people will choose the outdoor unit for gas, even electric, I did not talk about, but you can also have electric units outdoors. People mostly will go with gas outdoors more than electric because first it's a bigger footprint. So if you don't have enough mechanical space in your mechanical room, and second, you don't need to build a chimney if you put it outdoors, so you save on labor cost of building a chimney. So the way the safeties for an outdoor unit, it varies from a brand to a brand. So each brand has its own way to make sure that you don't freeze outside. But mostly what people do, you will heat trace everything that's outside. You need to heat trace it coming to the unit. The unit itself, if when you choose outdoor unit, the connections will be from the bottom of the unit. So once you install it on the roof curb, all the connection coming from the building goes through the roof directly through your unit. Inside the unit, we have normally open valves, so if there's any water outage, it will drain immediately. And you have the option to keep the tank warm. So we keep always the tank at the warmer temperature. So by radiation of the heat inside the tank, it will reheat your enclosure. You can also have a heater inside the unit to also reheat your enclosure. So these are mostly what people use for outdoor application. Another option you have is the steam to steam humidifier. So let's say you have an existing boiler inside the hospital or at school or whatever, and you want to use the steam from the boiler, but most of the boilers use a lot of chemicals inside of it. And some engineers will say, no, I'm not pushing these chemicals directly to the space. So you will take the steam from your boiler, tap it through your steam heat exchanger here, and get clean steam out of it. Or you can say, no, I don't have a lot of chemicals inside the boiler. I just want to push it directly to the space. So then that's what we call direct steam application. So you take the steam from your boiler and you pass it through all these components here, which are a strainer. It's like a filter, the steam separator, make sure that there's no water mixed with the steam valve to control your capacity, a float, the temperature sensor to make sure you're at the steam level, and the grids. So that's mostly what you would need to do direct steam application. Now keep in mind, both the steam to steam unit and the direct steam application are low pressurized steam. So we're talking between 5 to 15 psi. Usually the pressure coming from your boiler are between 50 to 80 psi. So to be able to use this technology, you need a PRV station, a pressure relief valve before these units to lower the pressure down to a maximum of 15 psi. So now we spoke about generators, so where you're boiling the water. And then you need to push this water somewhere. So that's where we get the grids. You have two options when you're designing grids. It's even you go with a single tube. So that's mainly for small to mid-size application where you just put one wand in the duct and you shoot humidification directly in the duct. Or you can go with multi-steam. In this case, you have the steam connection here. So the steam will go through these grids and then condensation will flow down and you have a condensation trap, which it doesn't show in this picture, and then you take it back to your drain. So the multi-steam, we use it mostly for bigger capacities or when you have a shorter absorption distance. So what's an absorption distance for people who doesn't know exactly what's the absorption distance? When you have a steam going from these grids, if you put your hand directly next to the grid, you will feel it's wet because the steam was not absorbed by the air yet. At some point, the steam is completely absorbed. So you put your hand a little bit further away, you don't feel the wetness or the steamy on your hand. That means all the steam was absorbed by the air. And you definitely need all the steam to be absorbed by the air before this grid hit the filter section or the coil section, because you don't want to condense on other components inside your system. So that's the absorption distance. For us to be able to give you a shorter absorption distance, we need to add more tubes. The more you add tube, the shorter the absorption distance is. So for you guys who are designing jobs, it's really important to say to tell Odell, okay, I have this section for my humidification. After 2 feet or 3 feet, I have another section. So make sure you guys fit into this 2 feet absorption distance. That's the only information we need. Well, how much distance you have, and we will design the product to fit into this distance. So most of the time, if your absorption distance is very small, you will see like you may get a grid with double row tubes. So you have 2 rows of tubes. Because as I said, the only way to minimize the absorption distance is really to add more tubes to it. Also, a very important point, I seen it in during my 18 years in selling humidifiers. A lot of engineers will give us the design condition. So let's say he gave us 10,000 CFM, 40% outside the air, and the air is coming at 55 degrees Fahrenheit. So we design the job, we go into the absorption distance he's asking for, and then once on site, he start condensing. And like, while we're condensing, we're supposed to be good. So you go on site and you see that design condition really changed. Like the outside air, it's not 40 now, it's 60, or the air hitting the grid, it's not 55, it's 52. So that would change completely your absorption distance. So make sure whatever you give as conditions during design is respected on site. Because if it's not, that will change completely the absorption distance. Because absorption distance is affected by the speed of the air, by how much outside air is coming, and what's the air condition hitting the grid. So if these conditions changed on site, then definitely your absorption distance is changing. Now, also when you're designing a job, you have the option to go with a standard grid or insulated grid. So why we insulate the grid? It's important to keep in mind insulation, that's what you will be, where you will be saving tons of energy. if you remember when I was talking about gas unit, I said, you have the condensing one and the standard one. There's like 4 or 5% efficiency difference. And that's not where you're going to save money. Where you're going to save money is really in insulating your grid. And why is that? Because the biggest waste of energy when you're designing a humidification job is the condensation coming from your grid. Because you have 212 Fahrenheit steam flowing through these grids, hitting your airstream, which is usually at 55 Fahrenheit. You will be condensing. And this condensation, that's money. That's water that you put money in it to take it to the steam level, cool it down, and just taking it back to the drain. So that's a total waste of money. And that's where the real saving is. Now, if you have a 20-pound job, like a small office or whatever, it's very small jobs. To be honest, if you insulate or you don't insulate, you're not saving much because you're not condensing much anyway. But if you have big jobs, when I talk big jobs, not necessarily huge jobs, like 100-pound plus, when you have a 100-pound unit plus, which were usually the gas units start to go to play, because before that you always go electric most of the time. So anything you have 100 pounds plus, that's where insulation makes sense. Because by insulating, you're minimizing, depending who you're speccing. There's different brands. Everyone insulate in a different ways. Some brands insulation are very efficient. Like you can minimize by 85% your condensation loss, which is a huge. The way they insulate is you take the grid, you put a SolarFlex insulation, this black insulation here, that's a SolarFlex insulation, and then you encapsulate this insulation with another layer of stainless steel. So you have a double wall stainless steel now with the SolarFlex insulation. That's how you can achieve a reduction by 85%. Now there's other brands that you will see, like they will have double wall stainless steel similar to the one I showed before, but there's no insulation between them. So that's an air gap that they leave. They're about, I believe, 66, 67% efficient. Another brand that will just use the PVDF insulation, kind of the black one I was showing earlier, but theirs is white, but they don't encapsulate with stainless steel. So for me, if I want really to give an advice, when you're speccing an insulated grid, I always recommend you to pick a brand that has a double wall stainless steel, or they are protecting their insulation with stainless steel. And there's a bunch of them. So, it's not just one brand that it will be like a spec stopper. There's a bunch of them. But why I don't recommend the brands that they don't have the stainless steel? Because this insulation, if it's not protected, with time, it will dry off. It's like in the airstream, it will dry off. You'll always have some water dripping from here. So the water at some point will come perforate your insulation, and the insulation will start flying into your airstream. So if it's not protected, after 5-6 years, you check into your insulation, you barely have any insulation left. So ideally, you always need to protect your insulation. So I'll give you kind of a fictive example just to highlight the importance of insulation and the absorption distance. That's also a point that I did not mention. I've noticed for a long time, there was like only one brand that were able to go very small absorption distance, which they were able to go down to 6 inches. And they took advantage of that, and they went and they told the engineers at the time, always spec 6 inches absorption distance. You don't have to worry about, like it's a peace of mind for you. Even if you have more, just say 6 inches. And this way, you don't need to worry about condensation. I mean, that's a big problem, and I'll show it to you in this example. So what we need from you, give us really the right distance you have. Like, I mean, if you really have 6 inches, which is rare. Like it's very rare that sometimes you don't have more than 6 inches. But if you really have 6 inches, it's fine. Because now everyone can do 6 inches. All the brands can do 6 inches. But if you have like 36 inches or 40 inches, don't say 6 inches only in your spec, because that will come with a price, which I'll show it to you now. So let's say you have a 20,000 CFM unit, 50% makeup air, dimension 9672, outside condition, indoor condition, air tunnel temperature, and you have 36-inch absorption distance. So based on these information, I know that I need 240-pound unit. So now, for a 36-inch absorption, 36-inch absorption distance, I need a grid with 6 tubes. So I need a multi-steam with 6 tubes to give you that. But I'll be losing 12 pounds per hour. So my reload will be 252 instead of 240 pounds. And I'm adding about 0.76 Fahrenheit of heat gain. It's not a big issue. Now, if you guys told me you want 6 inches, for me to be able to give you 6 inches, I need to give you 31 tube instead of 6 tube. So as a first cost, it's costing your customer way more money. And the worst is the running cost, because now instead of condensing 12 pounds per hour, you're condensing 40 pounds per hour, because you have much more tubes running steam into it and condense. And now your load loss is to 80 pounds per hour. And the heat gain is 3.5 Fahrenheit, which you will need to cool it back down. So that's a total waste of energy. Now, I'll take the same example and add the insulated grid. Again, depending on the brand you're using. I mean, you know, I definitely here, I'm you know, these slides are more like with our company, but again, any insulated grid is better than non-insulated. So if I take the same example, the 6 inches, which is like the worst case scenario, I still need to give you 31 tube. There's no way for me to have less tubes even if I insulate. But now instead of losing 40 pounds per hour, I'm losing only 6 pounds per hour. So when I talk about the saving with insulation, that's where it is. So now instead of having a 280-pound unit, you'll have 246-pound unit. The big saving again is in the heat gain. Instead of losing 3.5 Fahrenheit, you're losing only 0.52 Fahrenheit. So that's really the big saving I'm talking about when you have big design jobs. It's really by insulating your grids. So, couple installation consideration that you need to keep in mind. The first one, I get a lot of question about it. How far away can I go from the generator to my grid? Like, let's say my grid is in an air handling unit. I have an electric unit in the mechanical room. How far away it can be? You can't go more than 50 feet to make it easy. When I wrote here, rule of thumb, 1 feet per pound, that's usually kind of just to give you an idea. So let's say you have a 20-pound unit. You can go 20 feet, 30 pound, 30 feet, 40 pound, 40 feet, 50 pound, 50 feet, but up to 50 feet. So if you have 200 pounds, you can't go to 100 feet. You need to stick to your 50 feet. Sometimes we can go 60, 65, 70. It's not the end of the world. What I recommend from you guys, because I believe most of you are engineers on this call, if you have more than 50 feet and you're designing a job, send a hand sketch to Odell, how many vertical run, horizontal run, elbows you have. And most of the time, if you are at 65, 70 feet, it will be fine. We'll just maybe upsize the pipe diameter a little bit, and you will be fine. But if you have 200 feet, don't even bother to contact Odell. It will not work. And I've heard a lot of my competition sometimes talking about, yes, it will work. It will not work. We're talking about atmospheric steam here. It can't work because you have like steam traveling for 200 feet, condensing all the way. You will end up with nothing at the end of your run. I mean, that's physics. So it will not work. More than 65, 70 max will not work. Ideally, stick to 50 feet. If you have pressurized steam coming from your boiler, that's a different story because you're pushing the steam, you're helping the steam to go. So yes, you can go to longer runs. Now, if you have more than 10 feet, you always need to use insulated hard copper piping. You can't go with flexible pipe, because if you go more than 10 feet with flexible pipe, the pipe at some point will start heating up for the steam and start doing a snake shape, and the condensation will be trapped inside this snake shape. So you don't want that. You always need to have a high limit and airflow switches as safeties. So to make sure if for any reason the fan stopped working into your system, you shut down your humidifier so you don't start raining inside your air handling unit or your duct. And the high limit, you also needed to make sure that if for any reason your air condition changed and you start reaching 85-90% relative humidity at the end of the duct, you want to modulate down the humidifier so you don't condense inside of it. Now, usually you will install the high limit at the end of the run. So you need to have it at the end of your duct or the end, to make sure that you don't trip it. Because if you install the high limit directly after your grid, when the unit starts running, it will trip your high limit, because at first the unit will go full blast and then start modulating down. So you don't want your high limit next to your unit. You want it at the end of the run. Usually we recommend 15 feet away from the grid. Same goes for the smoke alarm. You don't want the smoke alarm directly next to your grid. I've seen it a lot in hospitals that anytime the grid start operating, it triggered the smoke alarm, because at sometimes like it will go full blast. There's like a big smoke going steam smoke, which will blow the smoke alarm. So you don't want that next to it neither. Now, also keep in mind, you always need some space for maintenance. So don't, keep that in mind. At some point, you need to do maintenance, maybe on the plumbing side, the electrical side, or the front side. So you need to install it in space where you can have access to it. Ideally, use 45-degree elbows instead of 90-degree elbows, because the steam will kind of travel easier. That's also the last point. I also get a lot of question about that. Let's say you have two separate rooms with two separate set points, but it's not big capacities. So some people will say, okay, you know what? I'll take a 60-pound electric unit and just put two grids in each room, and I'll control it this way. You can't control two separate zones with the same humidifier, because the humidity will travel the easiest way. If in one room the ducts are bigger, or the demand is bigger, or whatever reason, the steam will go to this way more than that way. So if you're using atmospheric steam unit, gas, electric, you can't have two separate rooms with separate condition supplied by the same unit. You need to get two units with two grids. Now, if you're supplying the same big space, like it's a big factory and you need a bunch of grids, but they are all shooting in the same space, then yes, you can have one unit, connect a bunch of the grids to it, and shoot in the same space. But if it's two separate space, you can do that. And ideally, you want because also I get this question, how do you control your humidification? Ideally, you control it with the return duct. So you have a return duct sensor that's reading what's your humidity and then telling the unit how it works. So mostly how the unit works, if you are less, far than 5% of your set point, so let's say your set point in the room is 40%, your return is at 32, then the unit will go full blast, 100% capacity until you reach the 40%, and then will modulate down between 40 and 35 all the time. So anytime you have more than 5% difference, you are at full blast. Between 5% and 100% what you need, so between 95% to 100%, you're modulating the unit to maintain your capacity. So most of the time, that's what the standard design look like. So you have your HVAC system, and you have the options to put your grids in even A, B, C, or D. Usually, I would ask people where they think it's the best, but today with Teams, and it's not that I don't believe it's very practical, so I'll just explain it to you. Uh, A or C are the best options for you because A, it's after the heating coil and after the cooling coil, so ideally that's where you want to put your grid. C also can be fine if you don't have enough space in A, because C, it's also after heating and cooling. You just want to make sure that you have a good absorption distance, because going out from a fan, the air may be more turbulent, so you would need a little bit more absorption distance, but you'll be fine. B, ideally you don't want it in B, because that's before the cooling coil. And if you're running cooling and humidification at the same time, which may happen on shoulder seasons, you want to make sure that you don't run them at the same time. So you want to interlock your controls so cooling does not run at the same time as humidification, because if not, you're just dehumidifying on your cooling system. You're not doing nothing. D, you definitely don't want to use D, because you can never put a grid before you heat the air. Because as I showed in the beginning, cold air cannot retain humidity. So you never put a grid before a heating coil. The grid should always be after the heating coil. So I know we're kind of running out of time, but I spend more time on isothermal because that's where I believe you guys will be designing most of your jobs. I'll touch base. I'll take maybe another 5 minutes, touch base very quickly on adiabatic, and then leave a couple minutes for you if you have any questions. So adiabatic, you have two options. The first option, what's what we call evaporative humidifier. So it's a fiberglass media, and then you have water running through this media. You have the option to recirculate the water or just take it to the drain. So usually if you're using this type of technology, this unit is installed inside the air handling unit. Like you build it as big as the air handling unit is like a filter wall with fiberglass media. You get the air through it, the water through it, the air will blow through the media, get cooled and humidified. Now you have options to have a UV lights to make sure there's no bacteria going through the media. Now, once it's time to stop the unit, you always need in your control sequence to stop this unit before you stop your air handling unit fan by at least 10 to 15 minutes. So you shut down this unit, you let your fan run for 10, 15 minutes, will blow through the media to dry off the media before you shut down the air handling unit. So we make sure we're not building any mold or any bacteria inside the filter, so the filter are really dry. So that's an option. A second option is that you have a built-in fan on this media, so now it's a standalone unit. It's not inside the duct or the air handling unit. So where we use this type of units, basically where we sell most of these units are mostly in data centers. Like you can sell it as a swamp cooler in a factory or anywhere just to use the cooling effect of it. But why people are using it mostly in data centers? Because if you look at the data center design, you have your crack unit here, you have your cold air aisle, and you have your hot aisle. So the air will blow from the crack unit through the servers. Now the air coming from this side, it's warm and dry. It goes through this unit here. We're talking about the evaporative media, will get cooled and humidified, and then goes back to the crack unit. So by doing so, you don't need any humidification anymore in your crack unit because it's done by this unit here. And you can minimize by 25 to 30% the capacity of your crack unit cooling system because you have the free cooling effect of the adiabatic process here. So hot, dry air goes through this unit, goes back more cold and wet, go to the crack unit. So you save a lot of energy on your crack units itself. And these units here are very easy to maintain. It's just, to clean the fiberglass filter every year and change it maybe every 4 to 5 years, depending how bad your water quality is. So that's where most people are using that. The second option you have in adiabatic is the high pressure system. So what's a high pressure system? You have 1,000 PSI pump pumping water through very small nozzles. So the water will break into, when it goes through the very small tiny hole of the nozzle, it will break into thin droplets, get evaporated and absorbed by the space, so it can cool down and humidify the space. So you have the 1000 psi pump, you have a set of valves, to do like the staging or the zoning that you need. And then you can have these nozzles, rack of nozzles installed directly into the space, or they can be installed inside the air handling unit itself. Pay attention, if you put it inside the air handling unit, you will need at least, depending on capacities, but you'll need between at least 4 to 5 feet of absorption distance to make sure that it's absorbed. Or if you put it in the space, you need a high ceiling floor to also make sure you're not wetting the people or whatever product is in the space. So where we use this application, mostly we use it in factory application. Let's say a printing industry. Printing industries usually have high ceiling, tons of printers generating heat during even winter, and you need humidification for the ink, you need humidification for the papers. So you shoot this sprayed water inside the space directly, you are cooling down, humidifying, and it's a free cooling because these units does not consume a lot of energy. Like the only energy you're consuming with this whole system is the 1000 psi pump, which is about 15 or 20 amps. So that's not big consumption, and you can go up to 2,500 pounds for each station, which is huge. You can also have different types, like you don't need just to have like the small nozzles. You can have these ones where you see like the small nozzles here, and the fan, you can install it in the space. You can install it on a wall. So you have tons of options. Finally, to use this system, which is the high pressure system I'm talking about, you definitely need an RO system. Why? Because these small nozzles, if you're pushing city water, there's like scale, like there's calcium, magnesium in the city water, it will clog your nozzle. So you can't use city water. Plus, you're spraying, when you spray the water, if there's scale in it, like there's powder that you're going to be spraying everywhere. So the only product that you can never use without RO system is the high pressure system in humidification. You always need to use the RO system. So how does it look like usually when you have an RO system? You have the dechlorinator here, so to take out all the chloride from the water, a water softener. Why we need the water softener before the RO? To protect the RO membrane, because if you push directly city water into the RO system, you'll go through your RO membrane very quickly. So you don't want that. So you put the water softener before, then from the water softener, you tap to your RO system. And then from the RO system, you go through a tank. You have the option to go with atmospheric tank or pressurized tank. People will go pressurized tank where bacteria is a problem, because when you have an atmospheric tank, the water is still, sometimes you may get some bacteria inside of it. So people may go with a pressurized tank to make sure it's all sealed and there's nothing happening inside the tank. And then from this tank, you tap to your RO system and you do your humidification process. I guess that's it for me.
Thank you, Ronnie. The floor is open for any questions anyone might have. You can unmute your mic, ask the question, or you can put it in the chat, whatever is better for you. Yeah, if there are no questions, then Ronnie, do you have anything else you want to kind of touch on?
No.
So, okay.
And anyway, guys, if you have, if you think about any question, or when you are designing at some point and you need something, you can reach out to Odell, and they'll be able to help. And you can always also reach out to me if you need my contact. Abdul can send it to you. So
yeah, if you guys have any humidification kind of projects or any questions about it when designing it, feel free to reach out to Odell, and we'll be able to help you out with anything you need. We do have one question that just came in. from Ali. Would the power slide be available for distribution? So the PowerPoint.
I mean, are you asking me? Or
Yeah,
me,
we can
me, I
get it
don't mind.
from Neptronic, and then we can send it over to you guys for sure. Okay. Thank you everyone for joining, and have a great rest of your day.
Thank you.
Thank you, Ronnie.
Thank you, Abdul.